Hey everybody, the purpose of this video is to get you some solutions to the hypothesis tests about Bend AP pass rates. This was a study I saw on the, or actually some statistics I saw on the news a few years ago. And basically I want to walk you through the template. You got a nice template here. I want to walk you through how to fill it out. Since we're testing a pass rate, we are definitely testing a proportion. So you're testing little p, not mu yet. The variable we're testing, since we're interested in Bend, we're talking about the Bend High School AP pass rate. That's what P is in this one. And we're trying to see if it's any different than the national average. The national average, I got to go back and check real quick. The national average is 59%. We want to see if Bend's is significantly lower than that 59%. So I'm going to make that red so you can see what I'm typing here. All right, that's our research hypothesis. The opposite of that would be P is greater than or equal to, and I got to go find, oh, there it is right there. Greater than or equal to 0.59 is totally fine if you want to put it that way. Many research articles just say it's equal to 0.59. If you guys want, you can say P is not less than 0.59. I mean, they all mean the same thing, essentially. So any of those three things are just fine. Pick one, whatever one you want to go with, and go with it. Slide that over a little bit. There we go. So there's your setup for your hypotheses. The two types of error. Okay, so a type 1 error would be saying that Bend's AP pass rate is less than 59%, when in fact it isn't. That's a false positive. Oops, I should spell saying correctly. That is a false positive. It means you came up with a positive test result that, yes, indeed, it is less. You believe this when you should have believed this. A type 2 is exactly the opposite. You believed this when you should have believed this. So that's saying that Bend's pass rate is not less than 59%, when in fact it is. All right. Which type of error would be worse in your opinion, and why? I can't wait to hear what you say about this one. I don't know if I have a feeling about which one will be worse. I could vote for the fact that a false negative would be worse, because if the AP pass rate were important and we didn't need to monitor it, and not catching a change might be detrimental. The question is, how important is an AP pass rate? I'm not really sure. So I'm going to let that one go and see what you guys put. We're going to use a z-distribution because this thing is definitely a proportion study. The test statistic and its correct variable. Oops, I should have had this out ready for us already. Hang on one second, friends. Let me fire up a TI. Sorry about this. Let's make a new TI-83 Plus. There we go. All right, so here she is. The data, we got to go to stat tests. We're going to go to one prop Z test. We're testing against 0.59. We have 109 passing tests out of 198. I want to come back to this and why we might be able to argue this is not a statistic and instead is a parameter. We'll come back to that. We're trying to see if it's less. Boom. And we'll go ahead and draw it. Real fast. There's your test statistic, about negative 1.13 with a p-value of about 13%. Make sure you put the z in there. I want to see that. I want to see that z because that makes me realize that you know that it's a standard deviation measure. I want that. Your p-value is about 13%, which the magic number is it's above 5. I want to talk more about that in class 2, why it doesn't have to be 5, but it will be in class. So it does not appear that anything is out of the ordinary here. We are within. It does not appear that Bend High School students pass the AP exams at a lower rate than the national average. Let's go back and spell all the words correctly. I look at my fingers while I type. Oops, at a lower rate. Make that red. There. Okay. There you go. Actually, I should put Bend High School students. So there you go. Bend Lapine, I guess. Yeah, Bend Lapine students. Bend Lapine students. Okay, and you could make a type 2 error. You could say that you basically said this, saying it's not less than 59% when in fact it is. The chance of a type 2 is a totally different ball of wax. We'll get into that in about a week. So there's your quiz. That's 10 points for you right there, as far as that goes. I do want to talk briefly about this. Since I had the data, and I don't know if this is the entire population, in other words, a census, or if this was a sample, but the numbers I was able to get was 198 AP exams were taken and 109 were passed. Now, if that in fact is the population of all the values, then, technically speaking, you wouldn't run a hypothesis test, would you? You would just go 109 divided by 109. 109 divided by 198 is 55%, which indeed is less than 59%. And there wouldn't be a margin of error. So you could simply say, yes, Bend-Lapine is lower by 4 percentage points. And then you can get into a fist fight about whether that's meaningful or not. If this is a sample, you're allowed to use a test statistic and a p-value. If it's not a sample, you're not allowed to use that. If it's a population measure, if it's a parameter, then you only get to use this 0.55. So that's something to think about when you run research studies. You want to make sure that you're actually testing statistics, and you're not inadvertently mixing in parameters. And I say this because very often I see folks that want to use things like linear regression on population data. Well, the whole point of linear regression is that you're actually fitting an average to a line. And if you try to use p-values along with that, you're treating it as a sample, even though it's not. So just something to think about. And I hope this helped you get through the Bend-Lapine one. See you.